All right, hello Algebra 1 students. Today you're going to be making your math folder notes for the sequence or chapter 5 folder. So the first thing you need to do is you need to get a blank piece of paper and you need to fold it in half, okay? Just like this. Then what you need to do is, yes, please get a lot of supplies today. You'll need maybe a marker, some highlighters, pencil, pens. You're going to need a lot of different colors today. So what you need to do is pause your video here, create what you see right here, fold your paper in half, draw a nice line, arithmetic on one side and geometric on the other. All right, welcome back, Algebra 1. Now that you have your paper set up, remember what these notes are for. These notes are to help you in the upcoming short cycle, so your first assessment, and it is also to kind of clarify or wrap up everything that you know about sequences. And so we're going to start with arithmetic. So we're going to have this arithmetic sequence: 14, 10, 6, 2, -2, ... Okay? That is our very first sequence. And I just want to make sure that you guys can see that. Okay. Nice. I might zoom in just a little bit so you guys can see how this looks. Let's take a look. Oh, there we go. So 14, 10, 6, 2, -2. Now remember when you are building a sequence, okay? Sometimes it's not helpful to see it in this form. Sometimes we'll ask you to write it like in a table form, which I'll do here in a minute. But what you need to remember here is that arithmetic, and yes, please, this is what I'll be looking for when I grade this. Mr. Evans and Mr. Reed's class might be looking for something different. But remember, the more detail you have in these notes, the better, because you're going to be able to use these over and over and over again. And so I want you to remind yourself that arithmetic belongs to that linear family. So I just drew an arrow up there and said, that belongs to my linear family. I'm going to bring this down even more so you guys can see it a little bit better. All right. So there is the linear family part. Now, every time you get a sequence, a lot of times it helps to just put this into a table format. So I'm going to put this into a table. You can do this if you're given a graph, if you're given the word problems. And remember, we use n and t of n. Don't worry, that just means x and y. It's a fancy x and a fancy y. Okay, let's put in some points. We know we're going to have our first point, second point, third point, and so on. Again, let's remember that this is the first term in that sequence. Okay, so the first term in the sequence is 14. So I'm going to put that in my table. The second term in my sequence is 10. Okay, the third term in my sequence is 6, and so on and so forth. So the question that you have to ask yourself now is, how are we building this table? Or how are we building this sequence? And you can see, okay, right here, I'm always subtracting 4. Okay, so I'm subtracting 4. If I go backwards, okay, if I go backwards, that means I have to take a step backwards. That means I'm adding 4. So 14 plus 4 is 18. All right. So now the question is, what's important? So I'm going to make a little what's important here. What's important? So the first thing that's important that you guys all have been looking for is that SG. What is the SG? Well, in this case, the SG is -4. Now, remember, I'm going to do a lot. Remember, you're trying to remind yourself what this means like in a year. This is not just for notes for right now. This is the sequence generator. Notice how I'm switching my pens. Okay, my pen color. Because I'm trying to put things that are important in my purple, so then I know. Okay, the sequence generator in this equals the M, which equals the slope. Remember, we're in the linear family, so this is important, okay? We have to know what our sequence generator is because that's our slope. Okay, the other thing that is important is this t of 0. And if you go to our table, there's our 0 point, so the t of 0 is 18. Again, I'm going to remind myself what t of 0 means. So in this case, t of 0 is the starting point. Starting point, which equals b, which equals the 0 term. Okay, so on your notes, you should have all of this with lots of different color. When I'm grading this, I'm looking to see, okay, are you not only finding the big pieces, but are you labeling them as well? You can use these on your upcoming short cycle, okay? All right, we're going to have another big equation, or we're gonna now talk about the really big stuff, which is, can you write the equations for these? So I'm gonna make this look nice here. Oh, there's my ruler. I tend to use a lot of rulers, guys, okay? So here is my equations. I'm gonna make equations. Now, there are two types of equations. Notice how I'm gonna draw my line here. The first type is known as explicit. Okay, there it is. There's the explicit equation. Now, explicit means that you can jump anywhere in the sequence, but this is what it looks like. I'm going to write it out in words first. We have T of n equals the sequence generator, SG, times n plus T of 0. So in this case, in this example, we have T of n equals -4 times n, and my T of 0 is 18. Okay, now I'm going to highlight a couple of things. I want to highlight the SG and T of 0 so you guys can see where those end up. All right, here is the SG, and there is my T of 0. Okay, just be aware of that. The other thing I'm going to label is explicit. Explicit means can jump anywhere in the sequence. So I'm going to make my, again, I'm using purple. I'm going to say can jump anywhere in the sequence. Ooh, I'm running out of room. Okay, all that means, guys, is that if I want to find T of 100 or the 100th term, I just plug in 100 and I've got it. Okay, all right, let's come over here to this side. So this side is going to be our recursive. Recursive. And recursive means it depends on the previous term. All right, I'm going to make this one a little bit lower so we don't run into room. So here's what recursive looks like. T of n plus 1 equals T of n plus the SG. And then you always have your T of 0 equals something. So again, I'm going to underline that. There's the SG, and there's the T of 0. So in this case, okay, this is what ours will look like. T of n plus 1 equals T of n. My SG is -4, and my T of 0 is 18. Okay. Notice the difference in those two types of equations, explicit and recursive. All right, I'm going to write down what recursive means. And recursive means depends on the previous term. The term I want equals the previous term -4. Okay. There it is, guys. One last thing to talk about before we move on to the next side, and that is what will the graph look like? Okay, so I'm going to come down here and I will make the graph. So we'll do the graph here. And I'm I'm going to make myself, yes, I do have a ruler here, so I'm going to make myself my axes. My T of n is my y, my n is the x. And remember here, our graph is somewhere up here like at 18, and we're always going down. Okay, this is not an exact of the graph, but that's what it looks like. So this graph right here is linear, it's discrete, okay? And that means you can't connect the dots. Remember, that's what discrete means. Do not connect the dots. All right, let's take a look at what your notes should look like. Your notes should be detailed, lots of color, okay? All of the equations written out and labeled. What does the SG mean? Okay, and I might bring this down just a little bit here, guys, so you guys can see this. Okay, if I bring it this way, no, I'm going to leave it up there. It's a little bit difficult for you guys to see. There we go. Okay, so that is what yours should look like. Again, lots of color, lots of detail. Okay, it always looks like this. My class, you'll be taking a picture of this and uploading it to Canvas. So that's what I'll be looking for. All right, let's go to this other side. This is going to be the geometric side. Okay, and we're going to do the exact same thing. I'm going to give you a sequence and you're going to get to write it out. So first, 1/9, 1/3, 1, 3, 9, ... That is our geometric sequence. 1/3, 9. Okay. All right, the next thing that you're going to be able to do is exactly what we did before. Put this into a table format. So I have n, T of n, I have 0, 1, 2, 3, 4, and so on. So the first term in my sequence is 1/9. The second term in my sequence is 1/3. And I have 1, okay, and then I have 3. Oh, now this is weird because we have those weird decimals in there, guys, but or fractions, but remember it's okay that we have fractions. Let's just think about what we're multiplying by. So, because I told you it's geometric. So I always start with the one I know. Well, if I'm at 1, I have to multiply by 3 to get 3. So let's check that. 1/3 times 3, or what's 3 divided by 3? Oh, it's 1. 1/9 times 3 is 3/9, which reduces to 1/3. So if I wanted to go backwards, okay, if I want to go backwards, I have to divide by 3. Now, when you divide by 3, remember it's just like you're multiplying by 1/3. So 1/9 times 1/3, and I'm going to leave it as 1/27. You're going to get a weird decimal if you put that into your calculator, but that's what it is. It's 1/27. Okay, so let's come down here to what's important. Again, what's important is our SG. And our SG in this one is times 3. Okay. Oh my goodness. And notice again, our T of 0 is again important, and that's at 127. So the thing I want you to point out on this guy, we already know that SG is a sequence generator, but here with the times 3, I want you to make sure this is not a slope. This is geometric, okay? It's a multiplier. That's what that means. It's not a slope, it's a multiplier. Be careful, this is no longer y equals mx plus b, okay? Yeah, so what I have written here says it's not a slope, it's a multiplier. Please make sure you write those things. So when you're looking at your notes, you remember that's not a y equals mx plus b anymore. So that does lead us next into these equations. All right, So let's do the equations. You'll notice that this one doesn't have as much writing because you've already defined what explicit is, so we don't need to redefine it. If you want to, you absolutely can. So let's talk explicit, okay? Explicit means I can jump anywhere I want to. So I'm going to write it out in words first, or symbols first. So T of n equals our starting point times the SG raised to the n power. So for our example, it looks like this. T of n equals 1 over 27 times 3 to the n power. Again, I'm going to underline or highlight, there's the T of 0 and there's the SG in that equation, okay? There's the starting point and the sequence generator. All right, let's try recursion now. So we'll have recursion on this side. So recursive formula. So our recursive formula is the same setup, except for instead of saying plus the SG, it's times the SG, but I'm still going to write that out. So recursive is T of n plus 1 equals T of n, but this time it's times the SG, and our T of 0 will equal something. Okay, so for our example, we have T of n plus 1 equals T of n, but this time it's times 3. Oh no, sorry guys, that is going to be times 3. And don't forget, you have to have this second part, and T of 0 equals 1 over 27. So let's take a look at where the SG is here. So here's the SG, and there's the T of 0 in our recursive formulas. Always, always, always remember that when you're writing these formulas, it's going to get tricky on that short cycle. Use this paper as a guide. This is geometric. It has no pluses or y equals mx plus b. It's a totally different equation. But notice the SG and the T of 0 show up in both of those equations. All right, last thing that we got to talk about with this guy is the graph. The graph, here we go. Make yourself a nice graph here. I'm going to be looking at T of n and n. And this is exponential. Again, it's still discrete, but remember exponential is where it's a curve. It's no longer a straight line. It starts off really slow, and then all of a sudden it gets larger, larger, faster. So this guy, again, I'm going to use my purple because I'm describing something, is going to be an exponential graph, exponential, and it's discrete, meaning I can't connect the dots. Remember, we can't have a half of a bunny. We can't have 3/4 of a bounce, so we can't connect the dots. All right. If at any point you needed to pause this video, okay, please pause it. I'm going to do this first part. So if you want to pause the first part and just focus on that, pause it here and make sure that your paper looks like this. Okay. All right. I'm going to show you the second half, which is the equations and the graphs. Pause the video here and make sure that your paper looks like this. In the end, guys, we're looking for a really nice notes that describes everything possible about this chapter 5. Make it detailed, make it nice and neat, lots of color. All right, guys, good luck on that short cycle coming up next week. You've been working hard. Finish it off with some good notes.